Is data science still the sexiest job in the 21st century? This is the question that comes up in my mind after recently reading in a LinkedIn post, where someone shared their frustration working as a data scientist before jumping into a software development role due to overlapping areas such as programming. Let me share the screenshot with you, and feel free to pause the video for a better understanding of what happens. As you can see, he emphasized the data science primary goal to provide actionable recommendations and implement machine learning model to improve business performance, like increasing profits. At the same time, he shares his real passion for being a software developer, anticipating that much of data science work will involve machine learning coding rather than business decision analysis. Ultimately, he believes that the role of data scientist has lost its appeal as one of the sexiest jobs in the 21st century. So in this video, I'm going to break down the 3 most common mistakes while learning data science, along with tips how you can set yourself up for long-term success. These mistakes include confusing data science with engineering, focusing solely on technical skills, and adopting a short-term perspective. By understanding and avoiding these mistakes, you can accelerate your learning curve to be a successful data scientist. If you stick to the end of this video, I will give you a bonus advice on how to accelerate your data science learning curve even faster based on my personal journey. Okay, let's dive in. Mistake number 1: overlapping data science versus engineering. In your search for data scientist roles, let's say at Silicon Valley, such as Microsoft and Apple, you may have noticed responsibilities related to natural language processing and computer vision. Many positions require a PhD in computer science and proficiency in TensorFlow, along with expertise in machine learning and deep learning frameworks for deploying models into production. Given the advanced products these companies have developed, like self-driving cars and AI engines, such as Microsoft Copilot and Apple Intelligence, it's clear that their data scientists are also engineering experts. Nevertheless, not all organizations are as advanced as those in Silicon Valley, and consequently, you need to choose the right data science position, which can be algorithms-driven, analytics-based, and statistics roles. In algorithmic roles, data scientists must have experience in building machine learning algorithms from scratch, requiring proficiency in TensorFlow, as standard Python libraries may be inadequate for tasks like image recognition. This role is ideal for someone passionate in more developer or programming roles. In analytics positions, data scientists should excel in extracting insights and patterns through analysis and visualization, along with proper business understanding, to create actionable solutions such as customer segmentations. In statistics-focused position, the role requires expertise in statistical testing methods, particularly hypothesis testing and A and B testing, often prevalent in clinical trials and quality control. To find the right role for you, start by identifying your strengths. Are you a math and coding geek from computer science background? Or do you enjoy visualizing patterns? Or did you come from a pure statistics background? No matter your background, an analytics role can be a great starting point, as proficiency in Python, SQL, and Excel is only the requirement. Initially, consider joining as a data analyst as stepping stone to gain a deep business perspective, which I will discuss in the next section. From there, you can advance into specialized areas like algorithms or statistics by taking online courses from Coursera or edX or Udacity, where these platforms offer so many specializations taught by industry professionals. We've covered how to identify the right data science role. Now, let's look at what other mistakes data scientist makes, that is focusing too much on the technical skills. This is the reason why I would recommend starting as data analyst, as previously mentioned. When learning data science, you've likely encountered popular online courses, such as Andrew Ng's on Coursera, which cover advanced topics like neural networks and deep learning. While mastering these subjects can be exciting, it's important to remember that a data scientist's primary goal is to derive actionable insights from high-quality data that drive business growth success. Business owners often lack the technical expertise to understand complex algorithms like XGBoost or support vector machines. Instead, they care more about insights that can influence their decisions. Overemphasizing algorithms can shift a data scientist's role from strategic contributor to maintenance worker. To effectively interpret insights, data scientists need strong industry knowledge and business terminology, like conversion rate or response rate business metrics. This is why starting as a data analyst, as I emphasized in part 1 of this video, is a best practice. In this role, data analyst will focus on analyzing dashboards and reports from business intelligence tools, such as identifying a 40% drop in sales during the summer using tools in SQL and Excel, then present the findings to the management team. While the data analyst role may seem tedious at times, it serves two important purposes. First, it helps you understand how the company operates, which can lead to valuable data science inquiries in the future. For example, even if there's a 40% sales drop, it might be seasonal, and this is an excellent opportunity to investigate the sales cycle root, cause analysis, and explore strategies to maximize revenue. This is how data analyst can add more value to the organization. Second, working as a data analyst allows you to develop essential soft skills and build a professional network. When analyzing customer churn in e-commerce, practice asking open-ended questions that foster creative thinking among your peers, such as, how does our churn rate over the past 3 years compare to industry standards? What could lead to customer dissatisfaction and churn? Could offering a discount to long-term customers reduce churn? When posing these questions, it's essential to listen attentively, ask for clarification, and foster a collaborative atmosphere without challenging your peers. Having strong peers can expedite idea approval by management team. While business insights are key, the final mistake many new data scientists make is expecting immediate results, when in reality, data science takes time and persistence. In engineering, especially in coding-heavy fields, it's common for professionals to anticipate immediate results. In data engineering, for example, a key responsibility is automating data ingestion from various data sources into a data warehouse. This process must achieve a high data processing rate, measured in records per second, to ensure scalability and capability in handling large datasets efficiently. Developing and optimizing this ingestion process can take weeks of careful planning. In data science, meaningful results take time, as improvements accumulate gradually. In my role at a financing company, I use a classification model to predict which customers are likely to miss loan payments, enabling timely interventions by debt collectors. The model reveals that habitual lateness is the primary driver of missed payments. After deploying the model, I observed that on-time visits by collectors correlate with higher rates of successful collections. Since changing customer payment behavior takes time, I focus on aspects within my control, such as striving for 1% improvement each month, like increasing the frequency of on-time debt collector visits. After 6 months, this incremental approach has yielded significant results, where missed payment customers drops from 20% to around 6%, fulfilling the business KPI target. Therefore, data scientists should adopt a similar long-term mindset. Beyond technical skills, success in data science requires continuous improvement in areas like communication, visualization, and predictive modeling. As Bruce Lee once said, "I fear not the man who has practiced 10,000 kicks once, but I fear the man who has practiced one kick 10,000 times." In data science, small, focused improvements over time lead to lasting success. Okay, this is my bonus advice as I promised before. Find a mentor from business consulting background like McKinsey, BCG, Accenture, Deloitte, etc. A great mentor with business experience doesn't just help you improve your technical skills, they help you develop the communication and soft skills that make you effective as a data scientist. If you're already strong technically, a mentor can guide you in presenting your findings, securing stakeholder buy-in, and making your work truly impactful. I can personally vouch for this. After 5 years in data science, I didn't start truly enjoying my work until my second year. In my first job, I was focused only on building machine learning models. While I loved the technical side, I realized I was missing the bigger picture. Business strategy and communication were never emphasized by my manager, whose experience has been purely technical. That all changed when I moved to a new company and worked under a boss with consulting experience from Accenture. He taught me to approach data science holistically, from problem definition to analysis, and finally, delivering actionable recommendations. The most fulfilling moment came when I successfully presented to the top management of an insurance company. It wasn't just about the model, but about communicating insights in a way that drove business decisions, and that shift in perspective completely shaped my career until now. Now, if you want to learn deeper how to make data science project more impactful, check out this video where I share an example use case, how to use 5 whys analysis to explain model insights into business users using IBM HR dataset from Kaggle. Don't miss it. If you found this video valuable, Hit the subscribe button so you can continue receiving tips and insights that will take your data science career to the next level. And don't forget to leave a comment. I'd love to hear how you're planning to apply these tips. Thanks for watching.